Hello friends, welcome to Indian Air Force Group X. Today's we are going to learn fundamental constants. First of all, the quantity is given and its symbol as well as numerical value is also given. First of the speed of light in vacuum. Symbol denoted by small c. Its numerical value is 3.00 into 10 to the power 8 meter per second. Gravitational constant. It is denoted by symbol is capital G and numerical value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Avogadro number N base A 6.02 into 10 to the power 23 molecules per mole. Universal gas constant. Symbol is capital R 8.31 joule per kilo per mole. Boltzmann constant K base B. Its numerical value is 1.38 into 10 to the power minus 23 joule per Kelvin. Stephen constant. It is denoted by sigma. Its numerical value is 5.67 into 10 to the power minus 8 watt meter square per Kelvin power 4. Per kilogram. Atomic mass unit small u is equals to 1.66 into 10 to the power minus 27 kilogram. Coulomb constant denoted by symbol small k. Its numerical value is 9.00 into 10 to the power 9 Newton meter square per Coulomb square. Epsilon naught is equals to 1 upon 4 pi k. Its numerical value is 8.85 10 to the power minus 12 Coulomb square per Newton is called Newton meter square per Newton into meter square. Biot-Savart constant denoted by k dash 10 to the power minus 7 Tesla meter per ampere square per ampere. Electron charge minus e. It is represented numerical value is minus k 1.60 into 10 to the power minus 19 coulombs. Electron mass of electron is 9.11 into 10 to the power minus 31 kilograms. Proton charge 1.60 into 10 to the power minus 19 coulombs. Mass of proton 1.673 into 10 to the power minus 27 kilograms. Mass of neutron 1.675 into 10 to the power minus 27 kilograms. Planck constant. It is represented by small h 6.63 into 10 to the power minus 34 joules second and 4.14 into 10 to the power minus 15 electron volts. Rydberg constant. Rydberg constant represented by its symbol is capital R base H. Numerical value is 1.10 into 10 to the power 7 per meters. Bohr's radius A naught 5 its numerical value is 5.29 into 10 to the power minus 11 meters. Solar and terrestrial data. Standard atmospheric pressure is equals to 180 and 1.013 into 10 to the power 5 Pascal, 1.013 bars, 760 Hg mercury, 760 torr. Acceleration due to gravity small g 9.81 meter per second square. Speed of sound is to dry air 20 degrees Celsius, 344 meter per second. Mass of Earth 5.98 into 10 to the power 24 kilograms. Volume of Earth 1.09 into 10 to the power 21 meter cube. Mean radius of Earth 6.38 into 10 to the power 6 meters. Mean density of Earth 5.52 into 10 to the power 3 kg per meter cube. Mean angular rotational speed of Earth 7.29 into 10 to the power minus 5 radian per second. Earth to Sun mean distance 1.50 into 10 to the power 11 meters. Earth to mean distance 3.84 into 10 to the power 8 meters. Mean orbital speed of Earth about Sun 2.98 into 10 power 4 meter per second. Sun mean radius 6.95 into 10 power 8 meters. Mass is equals to 1.99 into 10 power 30 kilograms. Moon mean radius 1.74 into 10 power 6 meters. Volume 2.20 into 10 power 19 meter cube. Mass 7.35 into 10 power 22 kilograms. Mean density 3.34 into 10 power 3 kg per meter cube. Acceleration due to gravity 1.62 meter per second square. Our first chapter is unit and its dimension. Such as measurement and observation foundation for physics is a science of measurement. SI unit and dimension of physical quantities. Physical quantities derived in which quantity measures under physics called physical quantity. Physical quantity is classified as fundamental quantity, as derived quantity is fundamental quantity as well as derived quantity. Here are two physical quantities, fundamental quantities and derived quantities. Fundamental quantities are those because they are obtained by most basic measurement that can be devised. Mass, length and time are fundamental quantities. Temperature, the amount of substance, electric current and luminous intensity. These are other basic quantities in physics. Derived quantities, quantities that are obtained by a combination of basic measurement are called derived quantity. Thus force, torque, density, etc. can be expressed in terms of mass, length and time through their defining equations. Product of numerical value and unit remains constant called a physical quantity. A system of unit, first is CGS, second is FPS, foot pound second system, third is MKS, fourth one is SI. First of all, we read about CGS system. This system of unit was set up in France and it is based on centimeter, gram and second. FPS system, the system of unit is also known as British system of units. It is based on foot, pound and second. MKS system, this system was also set up in France. It makes us meter, kilogram and second as the fundamental unit of mass, length and time. A system of unit is said to be coherent if all the derived unit can be obtained by multiplying or dividing its fundamental units such that no numerical factors are introduced. SI. The units of mass, length and time can be used to obtain the units of physical quantities in mechanics only. The basic SI units are given in the table below. Length, mass, time, temperature, amount of substance, electric current, luminous intensity. Unit meter, kilogram, second, Kelvin, mole, ampere, candela. Symbol meter, small m, kg, second, kilo, mole, ampere, cadmium, candela. Supplementary units: plane angle, solid angle. Unit radian, steradian. Symbol is RAD, SR for steradian. Radian denoted by RAD. Rad. Different unit of system, physical quantity. Length, mass, time. CGS, centimeter, gram, second. Meter, kilogram and second, MKS value. Above part is international system of units, which accepted internationally in 1960 called SI system. Definition of fundamental units. Meter. 1 meter is defined as distance containing 16,50,763.73 wavelength of arranged light emitted by pure krypton -86 krypton power 86 in vacuum. Kilogram. 1 kilogram is defined as the mass of platinum iridium cylinder alloy kept at International Bureau of Weighs and Measures, Paris. But other way define 1 kg mass of 1 liter pure water at 4 degrees Celsius is called 1 kilogram. Second, 1 second is defined as the time duration in which cesium 133 atom completes 9192 631 vibration in atomic clock called 1 second. Ampere 1 ampere is a constant current which, if maintained in each straight parallel current carrying conductor of infinite length and negligible cross section held 1 meter apart in vacuum produce force per unit length into 2 power 10 power minus 7 Newton per meter between them called 1 ampere. Kelvin modern thermodynamics using triple point of water as a basis of temperature. Triple point of water is at temperature 273.16 Kelvin, at which water coexists in all the three phases like ice, water, and vapor. 1 Kelvin is the fraction of 1 upon 273.16 of thermodynamic temperature of triple point of water. Mole 1 mole is defined as the amount of substance that contain as many elementary entities, quantities of molecules, as there are numbers of atoms in 0.012 kg carbon minus 12 1 mole carbon 12 contains 6.02 into 10 to the power 23 atoms. It is constant is called Avogadro number. Example: CO2 ratio 0.044 kg 12 plus 16 into 2 is equal 44 gram. Carbon dioxide gas contains 6.02 into 10 to the power 23 molecules. Candela 1 candela is luminous intensity in a perpendicular direction of 1 upon 60,000 meters square. Surface area of black body at freezing point of platinum 2042 Kelvin under the pressure of 1,1325 Newton per meter square. Define supplementary fundamental units. Radian, steradian. Radian. Here see from figure 1 radian. When we join origin of circle to its circumference by angle theta, then length created on circumference, this is known as 1 radian. Hence, for plane angle, arc length upon radius, phi is equals to length upon radius. Let r is L is equals to r, then phi is equals to L upon r upon r is equals to 1 radian. Hence, 1 radian is the angle subtended at the center of circle by an arc equal to in length to the radius of the circle. In other way, if arc and radius are equal, the plane angle is 1 radian. What is steradian? Steradian is that in a SI unit of solid angle, it is angle subtended by a part surface area of a sphere at a center. Measures of solid angle is the ratio of surface area of square of radius from one point of solid angle. Therefore, solid angle is surface area upon radius square. Surface area is equals to dA. Radius is equals to r. Put the value of surface area and radius in equation 1. Then solid angle is equals to dA upon r square. Let us put dA is equals to r square in equation. Solid angle is equals to r square upon r square is equals to 1 steradian. Hence, 1 steradian is the solid angle subtended at the center of a sphere by its surface area, which is equal to square of radius of circle, called 1 steradian. Parallatic second. Standard units. Parallatic second. It is defined as the at which arc of length of 1 astronomical unit is equal to 1.496 into 10 to the power 11 m subtended as angle of 1 second of an arc. 1 parsec is equal to 3.08 into 10 to the power 16 meter, 3.26 light years. Light years, it is distance traveled by light in 1 year in a vacuum of free space or year. 1 light year is equal to 9.46 into 10 to the power 15 meter. Astronomical unit. Fermi 10 to the power minus 15 angstrom. Angstrom, Reynolds, 10 to the power minus 2 meter square nanometer, 10 to the power minus 9. Micron, 1 micron 10 to the power minus 6. Kilometer, 10 to the power 3 meter. Astronomical unit, AU, 1.496 10 to the power 11 meter. Light year, 9.46 10 to the power 15 meter. Parsec, 3.1 into 10 to the power 16 meter. Atomic mass unit, AMU, 1 AMU is equals to 1.66 into 10 to the power minus 27. These questions are directly put up in Indian Air Force textbook. So learn it from bottom of your heart such that you can mark correctly in paper. Milligram, 1 milligram 10 to the power minus 6 kg. Gram, 10 to the power minus 3 kg. Pound, 1 pound is equal to 0.453 kg. Quintal, 1 quintal is equals to 100 kg. 1 ton is equals to 1000 kg. Mass, minute, 1 minute 60 second. 1 hour 16 to 60 is equal to 3600 second. Hence move ahead.